Lesson 41, finding rates of change and slope. A rate of change is a ratio that compares the change in one quantity with the change in another. And they give us the example of a speed of a car. Whenever you are riding with your family, your mom, your brother, your sister, whoever, and you're driving down the road, the car always tells you how fast you're going. This is a ratio that is a rate of change. Your car tells you how fast you're going in, whoops, I haven't changed to a pen yet. It tells you how fast you're going in, seriously, miles per hour. Okay, or you probably think of it as mph, but this is the ratio. So on your way to Clarksville, the speed limit is 60 miles per hour. That's the ratio. On example 1, it says the graph shows the relationship between the distance traveled and the time traveled of a car. Find the rate of change. Okay, so we want to know the rate of change from this point right here to this point right here. Well, I can look and see that we're talking about distance in miles and time in hours, so it would probably be a good idea for me to continue to use miles per hour. Okay, and from this point I'm at 60, and this point I'm at 20, so the difference there is going to be 60. And the time here is 1 hour, and the time here is 2 hours, so the difference there is going to be 2 minus 1, which is just 1, which gives us 60 miles per hour. Pretend like that's all one thing. The fees shown below are for canoe rentals. What is the rate of change for rental fees? Okay, so what we have is that for 3 hours it costs $22.15, 6 hours is $37.15, and 9 hours is $52.15. So what we're going to do is we're going to use two of these points to help us solve. And whenever we're finding a rate of change, we're also finding the slope. And I want you to know that the slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay? So whenever we have this, we have x and we have y. Okay? So we want to know dollars per hour. That's going to be the rate. So what I have is I have x1, y1, and I have x2, y2. So I'm going to use this information and plug it into my formula here. So m, or my rate of change, my slope, is equal to y sub 2, which is 37.15, minus y sub 1, okay, I'm done with this one, y sub 1, which is 22.15, I'm done with that one, over x sub 2, which is 6, minus x sub 1, which is 3. Well, when I subtract these things, 37.15 minus 22.15 is going to get me $15 over 3 hours, which will reduce, I can divide those, to $3 per 1 hour. So that is the rate of change. Okay, so for every additional hour, you're going to be charged $3 more. The slope of a line is a rate of change, the ratio of the vertical change or rise to the horizontal change or the run. We know that slope is always talked about as rise over run, which is why for our formula we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1, because you know that when we look at a graph, the rise is the y, that's the vertical. Okay, this is the y, and the run is left to right, and that's our x. So that's where this is coming from. So it wants us to find the slope of these lines, and I have line A and line B. I'm going to help you find the slope of line A, and I want you to do the slope of line B on your own. So line A, I have two coordinates, one here and one here. This one is 0 and then up 1, 2, 3, 4. So this is 0, 4. And this one is 1, 2, 3, 4, 5, 6, 7, 8, 0. Okay. And we're going to use x sub 1, y sub 1. Remember, our coordinates are always x and y. And I have x sub 2, y sub 2. Okay, so my formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And what we're going to do is plug in. So y sub 2 is 0. That was this. Oops, that part. Minus y sub 1, which is 4. So I'm done with that one. Over x sub 2, which is 8. Minus x sub 1, which is 0. So what I end up with is 0 minus 4, which is negative 4. Over 8 minus 0, which is 8. Which reduces to a negative 1/2. Final answer. Horizontal and vertical lines. A horizontal line is y equals c, where c is a constant, and the slope is 0. And a vertical line is x equals c, where c is a constant, and the slope is undefined. Let me show you an example. If I have a graph, and on my graph, I want to know where y is equal to 2. Okay? This is y equals a constant. 2 is a constant. So we're going to go up 1, 2 on the y, because we all know that this is where y is equal to 2. But also, if I went right 1 up 2, y is equal to 2 there as well. I could go right 5 up 2. Y is still equal to 2 there. I could go left 3 up 2. Y is equal to 2 there. You'll see that I'm just dotting along here. This is going to be, pretend like it actually hits, my line for y equals 2. And I have a slope of 0 because it's not rising or falling at all. It's just staying that constant flat horizontal line. The same thing works for x equals, let's say, negative 3. If I have x equals negative 3, and I want to know where that is, from the origin, you would tell me to go left 3. So 1, 2, 3. So this is my point for x equals 3. But the same thing works for this, only vertically, because I can go negative 3, and I can move up 1. My ordered pair here is still negative 3, 1. So x is still equal to negative 3. So what I end up with is this vertical line whenever I have x equals. Number 4, it says determine whether each pair of points lies on a horizontal or a vertical line, then find the slope. So we're going to start doing this just by finding the slope. So I have x sub 1, y sub 1, x sub 2, y sub 2. So I have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's very important that you go ahead and just label these so you don't make a mistake. Okay, so y sub 2 is 1 minus y sub 1, which is 1, over x sub 2, which is 8, minus x sub 1, which is 5. So I have 1 minus 1, which is 0, over 3, and 0 over 3 is just 0. So what kind of a line has a slope of 0? I hope that you remember that was a horizontal line. Okay. Now on B, I'm going to prove to you why a vertical line has an undefined slope. I have my x sub 1, y sub 1, x sub 2, y sub 2, and I'm going to plug them into my equation. I'm not going to rewrite it. So I have 9 minus y sub 1, excuse me, so 1 over 3 minus 3. So 9 minus 1 is 8 over 3 minus 3 is 0. Well, 8 over 0, if you have your calculator on you, please punch that in and see what it tells you. It's going to give you an error. Okay? Because we don't know how to divide by 0, so this is an undefined slope, and that means that this one is the vertical line. The graph and the table show the relationship between the distance and time of a car. Find the slope and what does it mean. So I'm going to show you this information, and I want for you to use 2 points and find the slope and tell what it means. On your own paper, Lesson 42, Solving Percent Problems. A percent is a ratio that compares a number to 100. Percent literally means per 100. Let me get a pen out here. So what we have here is that 25% of 20 is 5. So this is the percent, 25% of the whole is the percentage. Okay? So the way that we would solve this, and to prove that it's true, is we would take 25%, which as a decimal is 0.25, of course, means to multiply 20, and when you plug that into your calculator, you get 5. Okay? So, what number is 75% of 200? The key to this is writing it exactly the way you read it. What number? We don't know what number, so let's put W. Is means equals. 75% we need to write as a decimal, which is going to be 0.75. Of means to multiply, and then 200. Well, now all you have to do is exactly what the problem is telling you to do. I have 0.75 times 200. So that is going to give me my W equals, and all I have to do is punch this into my calculator, which is going to give me 150. Final answer. 150 is 75% of 200. On B, I want you to try and work this one on your own. Remember to write it exactly the way that you read it first. So go ahead and pause the video at this point. On B, it says what number? We don't know what number, so we start by putting W. Is, we know, means equals. 120%, remember that to change a percent to a decimal, we have to move that decimal place 2 times away from the percent sign, so we have 1.2. Of 50, excuse me. Of means to multiply, and then 50. So all we have to do is punch that into our calculator, 1.2 times 50, and that gives us our W, or our number that we're looking for, equals 60. Final answer. Okay, we can also write percents as a proportion. Okay, so for example, 10% of 50 is 5. We have the part over the whole equals the percent that we're talking about over the whole percent. Okay, the percent we're talking about, the whole is always 100%. So on A, we'll write that one right here. Okay, what number is 120% of 25? Well, we're talking about what part of it, so we don't know that right now. Of the whole is 25. Equals, and the part we're talking about, we want it to be 120%, and the whole percent is always 100. My pen isn't working, I hate having to do it like this. So then all we have to do to solve the proportion that we have here, is to cross multiply. So we have 100 times x, which gives us 100x, equals 120 times 25, which is 3,000. And to get x by itself, we divide by 100 on both sides. 100s cancel, leave me with x equals 30. Okay, so what I want you to do is I want you to beat on your own paper. Example 3. Lee receives $1,278.91 in gross wages every week. Excuse me. However, 33.85% of the gross earnings is removed for taxes and other deductions. Using an equation, determine the net pay. So we want to know how much he, it says that he receives the $1,278.91, but his net pay is what he would get before that deduction. So I know that he's going to lose the $33.85 out of his check, okay, for taxes and other deductions, and it wants us to write an equation to determine the net pay. Okay, so I know that the gross pay is this amount, and this 33.85% is going to come out. So we have that $1,278.91, and I know that the deductions is going to be 33.85% of that. Now, to change, just because there's a decimal here doesn't mean that it's already in decimal form. I still have to move that decimal 2 times. So it's going to be times 0.3385, and that's going to give me my deduction, 432.911035. So I'm going to round that to 2 decimal places because I'm dealing with money, which is going to be 432 and 92 cents, or 91 cents, excuse me. And to find his net pay, I now need to take his gross pay and subtract the deduction to find his net pay. So it's going to be this $1,278.91 minus the deduction of 432 and 91 cents. Whoops, 91 cents equals, and when I subtract those, I get $846. Okay, so that's our final answer. Last one. Raul worked 45 hours at $7.50 per hour during this month. If he saves 30% of his monthly earnings, how much will he have saved this month? Excuse me. Before I can figure out how much he saved, I need to figure out how much he has made. So I'm going to take 45 hours times the hourly wage that he's getting, which is $7.50, so 7.5. So he's made $337.50. But I also know that he's going to save 30% of this amount. So I'm going to take this times 30%, which I know is going to be, move my decimal over 2 times, 0.3. And when I do that, I get 101.25. Please excuse my bad Finnish. So this month he saved $101.25. That's all I have for you today. I hope you have a good night, and I'll see you in class tomorrow.